Now let us discuss how the specific resistance of a given wire is found out using meter bridge. Apparatus required. The meter bridge, which has got a 1 meter long manganese wire, a Leclanche cell to provide the necessary voltage or current, a galvanometer to find out the balancing position or null point, the resistance coil for which the specific resistance and the unknown resistance is to be found out, which is also made of manganese, and the known resistance box. A known resistance, we will call this as Q, which we will use in the equation. So the connections are given as follows. The positive of the Leclanche cell, which is a carbon rod, is connected to the left end of the meter bridge. We will take it as A. The position is A now. The negative, the zinc rod of the Leclanche cell, which is immersed in the ammonium chloride, is given connection to the other end of the meter bridge, which is taken as B. The unknown resistance, we will call it as P, for which the specific resistance to be found out is connected in the left gap of the, you can see a gap here, so it is connected in the left gap. The galvanometer is connected in the middle, and the other end of the galvanometer is connected to a pencil jockey, using which we will find out the null point. On the right gap here, you can see a gap here. The known resistance is connected between the right gap. Now to begin the experiment, we have to put 2 ohms in the known resistance Q and enter it in the tabular column like this. So known Q value is 2. Now the experiment is performed like this. Take the jockey, keep it in the left end, that is A position of the meter bridge. Now you can see the deflection of the galvanometer towards the left side. I will now place the jockey position to the B end, the other end, and you can see the deflection in the galvanometer is onto the right side. This is called opposite deflection. This ensures that the circuit is okay, circuit is working well. Now to find out the null position, I have to start once again from A, position A, move the sliding jockey, and then looking at the galvanometer position. And as I slide it to one position, you will find out that the deflection in the galvanometer, that is the current, is coming to 0. Now when it exactly comes to 0, that's where we are getting the null point. And the reading on the scale is noted down, which is 60.7. So 60.7 is taken as your L1 from A, the position A to the jockey, 60.7. So I am just noted down as L1, 60.7. 100 minus that L1, you subtract 60.7 from 100 and write it down here as L2. So the experiment is repeated by changing the position of Q to 3 now. So the Q is now made as 3. The entire experiment is done once again by moving the sliding jockey from A until you adjust at a 0 deflection. The galvanometer. Now the reading is noted down as 52.3. 52. So this will be noted down as L1. L2 is found out by subtracting L1 from 100. You repeat the experiment by changing the Q value as 4. Note down the same way L1 as well as L2. Repeat the experiment by changing Q as 5 and do the same. We can find out the unknown resistance P1 by using this formula, Q, which is 2 here, into L1 divided by L2. Q into L1. You can find out this. Similarly, you can do for the other known values of Q. Now the experiment is repeated by interchanging the position of the known resistance and the unknown resistance and the known resistance. You have to remove the connection from the right gap. The known resistance is removed from here and connected to the left gap. Connected to the left gap, attached here. And the unknown resistance is removed from here. You have to remove this unknown resistance and then connect it to the right gap. So the experiment is repeated once again for the same currents, same resistances 2, 3, 4 and 5. The entire process is done once again, and the readings of the balancing point are noted down as L3. 100 minus L3 is L4, and the process is done for known resistance of 3, 4, 5. The formula now changes. The unknown resistance is now called P2, is given by the formula Q into L4 divided by L3. L4 divided by L3. The average of the two, that is P1 and P2, average will give you the unknown resistance P. So each time you have to find it out and then take the average of it. Average P is noted now. Now that is put into the equation to find out the specific resistance. Rho is equal to P into pi, 3.14. R is the radius of the wire for which we are finding the resistance, and L, which is the length of the wire. So to find out the radius of the wire,